Hi everyone. In this video, we're going to answer some problems involving related rates. Okay, for the first problem, we have this. A conical cup is 4 centimeters across and 6 centimeters deep. Water leaks out of the bottom at the rate of 2 cubic centimeters per second. How fast is the water level dropping when the height of the water is 3 centimeters? Okay, so let's start. Okay. In answering related rates problem, mapapansin talaga natin yung mga keywords. For example, ang keyword natin dito ay merong per second. Okay? So, pag nakakakita kayo ng mga per time, ganyan, related rates yon. Okay. So, let's start. In answering word problems, ang pwede natin gawin, una, let's try to draw a diagram of the problem as much as possible para makita natin kung yung relationship ng mga variables natin, anong pwedeng gamiting equations, anong pwedeng working equations, etc. Okay, so first, let's have this. A conical cup is 4 centimeters across and 6 centimeters deep. So, conical cup, so that's a cone. Let's try to draw a cone. So it is 4 centimeters across. 4 centimeters across. So that's 4. And 6 centimeters deep. So that is 6. But according to this problem, may water sa loob. But take note, of course, the water inside the cup takes the shape of the cup, which is cone. Okay? So, ibig sabihin, yung water na nandun sa loob, ang shape din niya ay cone. Okay, so let's assume that the height of the water is h. So, the height is h. And okay. So, since cone to, alam natin na ang cone, hindi lang sa height nakadepende yung volume. But also, dun sa radius ng base. Okay, so, let's say that this distance r. Okay? So, let's declare variables. Let V be the volume of the water inside the conical cup. And what do we know? We know the water leaks out of the bottom at a rate of 2 cubic centimeters per second. Meaning, the change in volume with respect to time is equal to what? So, negative 2 cubic centimeters per second. Bakit negative? Because nag-leak yung water. Ibig sabihin, yung water inside ay nauubos. Okay? So, may leak yan eh. Okay? So, we have H, we have R, we have V. Okay, so pwede na nating tingnan kung ano yung magiging working equation natin. So, what will be our working equation? Again, ang working equation natin, since may volume tayo ng water, that means we want the volume of the cone to be our working equation. Okay, anong volume ng cone? That is 1/3 by r squared h. Okay, so that's the volume of water. Pero may konti tayong problem dito. Ano yun? Take note that the right side of the equation concerns r and h. Okay? Pero ano lang meron tayo? Okay, so let's see what is being asked. How fast is the water level dropping when the height of the water is 3 centimeters? So mathematically, ano yung goal natin? How do we write that in terms of derivative? So ibig sabihin, gusto natin malaman gaano kabilis ito bumababa. So what is our goal? Our goal is, mathematically, how do you write that as derivative? That is the change in height. So that is h. So dh dt. Evaluated when h is 3 centimeters. And actually, we are expecting this to be negative. Bakit? Kasi, syempre, bumababa yung water level dito at any given time. Okay, so since h is decreasing, we are expecting that its derivative must be negative. Okay? Okay, but there's a slight problem here. What is that? Take note that the volume of a cone concerns two variables, r and h. But we are only given h. Okay, so anong gagawin natin? Well, what we're going to do is to find another relationship of how can we relate r and h in this problem. Okay, so ito yung figure natin. So dito lang tayo magfo-focus. Ano mapapansin natin dito? Yes. Tama yun, no? Meron kayong mapapansin na meron tayo actually dalawang right triangles dito. Itong malaki at itong maliit. Okay, so let me draw that. So mapapansin natin, ito yung sinabi nating R, ito yung H natin, tapos yung buo, ito yung 6. Ngayon, ano na lang tong measure na to? Okay. So, since half lang ito, half lang yan nito, so this means this is equal to 2. Okay? So, ano meron tayo? We have similar triangles. Okay, ano ulit ang makukuha nating equation from this? Similar triangles. So, paano yung similar triangles? Yung ratio nung netong malaking side over itong maliit na side, equal siya dun sa length nito over the length of this. Okay? Ibig sabihin nun, 6 over h is equal to 2 over r. Paano ulit natin ito nakuha? This 6, so that is 6, ito yun, over h, ito, equal to 2 over r. Okay? So, dahil ang meron lang tayo ay h, kailangan nating isolve yung r in terms of h. Okay? So, from here, pwede nating makita na r is equal to, so that's all for r. So, pag nag-cross multiply kayo, this is 6r equals, so 6r equals 2h. Okay? So, r is equal to 2h over 6, or this is equal to h over 3. So, we can now substitute this r to this equation. Okay? Okay. So, if we substitute this r to this equation, what do we get? So, v now, thus, v is equal to 1/3 by, take note that r is h over 3 squared h. So, simplifying this, what do we get? 1 over 3 by h squared over 9h. So, this means we have pi over 27 h cubed. So, that is v. So, anong next na gagawin natin is we get the derivative of this v in terms of t. So, getting the derivative of v with respect to t, we have dv over dt is equal to, so constant pi over 27, the derivative of h cubed with respect to t is 3h squared dh dt. Okay? So, ano mga alam natin dito? We have the value for dv over dt. Ito yun. Have a value for h, which is 3. So, solve na lang natin yung dh dt. Okay? So, we plug in the values of h and dv. So, dv is negative 2. This is equal to pi over 27. 3 times h is 3. So, 3 squared dh dt. Okay, then we solve for dh dt. 3 times 3 squared is actually 27. So, magka-cancel to. Ano matitira? So, dh dt is equal to, magka-cancel to, yan. So, dh dt is equal to negative 2 over pi centimeters per second. So, that means that the height is dropping at the rate of 2 over pi centimeters per second. Okay. All right. So now let's proceed with this problem. A roller coaster has a track shaped in part like volume of decors. Given this equation, x cubed plus y cubed equal to 6xy. And this is the graph of the given curve. When it is at the position 3, 3, its horizontal position is changing at 2 units per second in the negative direction. How fast is its vertical position changing? Okay, so let's answer this. But before that, let's recall ano yung horizontal position and ano yung vertical position if you're given any xy or any coordinate xy. So suppose this is coordinate xy, nasaan dyan yung horizontal and nasaan dyan yung vertical position. Suppose this is point xy. This is suppose point xy. Asan dito sa xy na to yung horizontal and yung vertical position? Okay, so let's observe this. Gumawa ka ng line from this point going down, this point going here. What is the measure of this? Yes, that is y. And the measure of this is x. So, hence, the horizontal position is x, while the vertical position is y. Okay? So we can now answer this problem. Okay, so what are the given information in this? Of course, we know that the horizontal position is changing at 2 units per second. So, paano natin yun isusulat? That means we have dx over dt equals what? Equals negative 2 units per second. Why negative 2? Okay? Because the direction is negative. Now, we want to know how fast is its vertical position changing. So our goal is, again, x is horizontal, y is vertical. So our goal is to find dy dt precisely when it is in the 3, 3 coordinates. Okay. So let's go now in the relationship between x and y. But it is given actually, no? It's given. It is x cubed plus y cubed equal to 6xy. So have x cubed plus y cubed equals 6xy. So what is the next step? The next step is to get the derivative of this with respect to time. Okay. So we get the derivative. Okay. So first, what is the derivative of x cubed? That is 3x squared dx dt plus what is the derivative of y cubed? It is 3y squared dy over dt, and this is equal to 6 times the derivative of xy. But take note, this is a product, so we shall use product rule in differentiating xy. So what is the derivative of xy? So that is left derivative of the right, so that is x derivative of the right, which is dy over dt, plus right, y, times the derivative of the left, which is dx dt. Okay. So we can now find dy dt. Okay, so let's see. So we now evaluate the following. Take note that we want to evaluate xy at 3, 3, and we know that dx dt is negative 2. Okay. So let's answer this. Okay, now we can now find dy dt. Of course, evaluate natin sa negative 2 and sa coordinates 3, 3. Okay, so let's evaluate. So this means we have 3 times 3 squared. What is the x dt? That is negative 2 plus 3 times 3 squared dy over dt. This is equal 6 times the quantity 3 dy over dt plus y, which is 3, and the x dt is negative. Okay, simplifying this, we have, okay, we compute this. This is 3 cubed times negative 2, so that is negative 54 plus, this is 3 cubed, so that is 27, dy over dt equals, so 6 times 3, that is 18, dy over dt, and here we have 6 times negative 6, which is negative 36. Okay, so to find dy over dt, what we're going to do is to isolate dy over dt on the one side of the equation, and lipat natin lahat ng constants sa right. Okay, so that means here, oops. So that means we have 27 dy over dt minus 18. What is 27 minus? What is 27 minus 18? That is 9. Okay, so 9 dy over dt equals, so negative 54, transpose natin sa right, so that becomes positive 54. 54 plus 54 minus 36 is equal to 18. Okay, so 18. So what is dy over dt? It is equal to 2. Okay, so that is 2 units per seconds. So what is our conclusion? The roller coaster is moving 2 units per second in the positive y direction. Okay. Now we're done with the first 3 problems. Now let's proceed to this one. This question is quite long. It has 3 questions. So we will divide the solution accordingly. Okay. So Andy, who is 6 feet tall, is walking away from a street light pole 30 feet high at a rate of 2 feet per second. Now for the first question, we have, how fast is his shadow increasing in length when Andy is 28 feet from the pole? The second question is, how fast is the tip of the shadow moving? And lastly, if he follows the tip of his shadow with his eyes, at what angular rate must he lift his head when his shadow is 6 feet long? Okay, so let's answer the first one. Again, when answering a related rates problem, what we're going to do is to draw a diagram of the problem. So let's start. Andy, who is 6 feet tall, is walking away from a street light. So there must be a street light. Okay, so this is the street light. Now suppose this is the ground. And suppose this is Andy. And suppose this is the light that is coming from the post. Alright. Now, suppose the distance of Andy from the pole, let's say that is x. And suppose the shadow, and suppose this length here, the length of the shadow is, let's call that s. Okay, so what we know is the height of the street pole, or the street light pole, which is 30, and Andy's height is 6. Okay, so we have now the illustration. So for the first problem, we want to know how fast is his shadow increasing in length when Andy is 24 feet from the pole. Okay, since we now have the illustration, we can now answer the problem. Okay, so we want to know, for the first problem, we want to know how fast is his shadow increasing when he is 24 feet from the pole. Okay, but first, we should write what we know. Okay. So what do we know about the problem? We know that Andy is walking away at a rate of 2 feet per second. So that means the change in x with respect to t is equal to 2 feet per second. Hey, is it positive or negative? It should be positive. Why? Since Andy is walking away from the pole, take note that x is increasing. Therefore, dx dt must be positive. Okay. But what is our goal in this problem? Our goal is we want to know how fast is the shadow of Andy increasing when Andy is 24 feet from the pole. Okay, so our goal is to find the change in his shadow's length with respect to time, precisely when Andy is 24 feet from the pole. So that is when x is equal to 24. Okay. Now, we want to know what equation relates x and s. So it will be our equation. Okay. Now, similar to item number 1, so you can see this is a very similar figure. These are what? These are similar triangles. Okay? So, paano ulit yun? Similar triangles. So, yung length ng mahaba over yung length ng maliit equal siya dun sa length ng mahaba over length. Diba? Okay? So, that is x plus s over s is equal to 30 over 6. Now, we simplify 30 over 6. What is 30 over 6? That is 5. Okay? So, now, if we cross-multiply this, what do we get? We have x plus s equals 5 s. Therefore, we have x equals 4s. Okay? From here, we get the derivative of this equation with respect to t. So that is dx over dt equals 4 ds over dt. But we want to find, our goal is to find ds dt. Okay? So do we know dx dt? Yes, that is 2. So we plug in 2 in this equation. Okay? So we have 2 equals 4 ds over dt. Now, that means that ds over dt is equal to 1/2 feet per second. Okay? So that means Andy's shadow is increasing at a rate of 1/2 of a feet per second. Okay? So that is the first part of the problem. Okay, now we proceed with the next question. So for the next question, we want to know how fast is the tip of the shadow moving. Okay? So as Andy walks in this direction, we want to know. So for example, dito na si Andy, we want to know how so we want to know how fast is the tip of his shadow moving. Okay. So how do we illustrate that? So what is our goal? Okay. So suppose that this whole x plus s is equal to, let's call m. Okay. So let m be equal to the sum of x plus s. So what do we want to know? Our goal is to find the change of m with respect to time. But it's quite easy. Why? Because we already have this equation. Okay, so from this two, that means that dm over dt is equal to dx over dt plus ds over dt. But then again, we know dx and we know ds, so we simply plug it in. Therefore, we have 2 plus 1/2, or this is equal to 5 halves. Okay, so 5 halves feet per second. So that means that the shadow of Andy is moving at a rate of 5 halves feet per second. Okay. Now we're done with the first two questions. Now let's proceed with the last question. So if Andy follows the tip of his shadow with his eyes, we want to know the angular rate. Must he lift his head when his shadow is 6 feet long? Okay. So let's try to illustrate the problems. So we want to focus on this part of the illustration. So suppose this is 6 and this is s. Where do you think is the angle? Okay, so the angle must be here, because why? That must be theta, because Andy, we want to know at what angular rate he must lift his head. So kapag dito siya nakatingin, so ililift niya yung eyes niya para malaman when this is already 6 feet. Okay, so how do we relate these three variables? Okay, of course, this is a right triangle. Therefore, from trigonometry, we know yung SOHCAHTOA. So, doon yung pwede natin gamitin. We can actually use tangent. Okay, so tangent theta is equal to opposite, which is S, over adjacent, which is 6. Okay, so we want to find d theta over dt when S is equal to 6. Okay, so let's now compute. But take note here, tangent theta, what is the derivative of tangent theta? That is, the derivative of tangent theta is secant squared theta. Okay, d theta over dt. This is equal to, what is the derivative of S? That is 1 over 6 ds dt. Okay, let's see kung ano yung mawala tayo. Okay, so far, meron tayong ds dt. Ito yun, 1/2. We want to find d theta dt. Wala tayong theta. So how do we find theta? Of course, we focus on this relationship of the variable. So this is where we get theta. Okay, so since we want to find d theta dt, when s is 6, we simply plug in 6 in this equation to get theta. Okay, so to get theta, we have tangent theta is equal to 6 over 6, or this is 1. But tangent is 1 precisely when theta is equal to pi over 4. Okay, now we have this. So we plug in ds dt and theta to this equation. So we have, now we plug in theta, so that becomes secant squared of pi over 4 d theta dt equals 1 over 6. What is ds dt? This 1/2. Okay, but what is secant of pi over 4? Secant, okay, secant of pi over 4 is equal to, okay, square root of 2. Thus, we have here square root of 2 squared d theta dt equals 1 over 12. Okay, therefore d theta dt is equal to 1 over 24. The unit for this is radian per second. Okay, therefore we can say that Andy should lift his head at a rate of 1 over 24 radian per second. Okay, so that is the end of this video. Hope you enjoy and hope you learned something. Thank you and good luck.